Alright, so you see here we have a quotient of radicals, and we're taking the fourth root of this fraction, and through a quotient property I know I can separate these into two separate roots. So I really have the fourth root of 8 and the fourth root of 9a cubed. And I go to simplify it, and I'm like, zut alors, oh my goodness. There's nothing that can be simplified, and I also know that I can't leave a radical in the denominator. This is not allowed. So I must rationalize the denominator. So this is a little bit trickier because I'm dealing with fourth roots, and I'm not dealing with square roots. So essentially what my goal will be, and I'll write it over here, underneath my fourth root, I would like to have what the equivalent would be of, well, the factors of 9 are 3 and 3. So I'm really going to want to have 4 3's underneath my radical. And I already have 3 a's, so I'm also going to want to have 4 a's underneath my radical. Because when I have 4 3's and 4 a's under my radical, they'll go away because the index is 4. So I have to figure out, if I already have 2 3's, which I have this guy and this guy, how else am I going to get 2 more 3's? Well, I know 2 more 3's is really just 9. I already have 3 a's, so I have 1, 2, and 3, but I need this last a. So I know I need to multiply this by another a. So my process here is deciding how am I going to get a perfect fourth root in the denominator so that I have 4 of whatever appears for the 3 and 4 of whatever appears for that a. So when I go to do this, let's ignore this part now. We're going to start in the bottom. So the whole point of this was that I was going to get a perfect fourth root. 9 times 9 is going to be 81. A cubed times a is going to be a to the fourth. Now in the top part, I have 8 times 9, that's going to give me 72, and I'm going to have an a. So now I got to simplify. I don't believe there is a perfect fourth root of 72 or a, so this is going to just stay. And in the bottom, the whole purpose of this was the fact that 81, well, that's 9 and 9, which both of those are 3 and 3. So I now have 4 3's, so I can pull out a 3. And I have a to the fourth power, which means I'm left over with an a on the outside when taking the fourth root.